Okay, as you get ready for the quiz over Module 6, the first thing I want to do with you is to just go back over how would I draw this if asked to draw each of the special types of segments. And I'm not talking about constructing it. We have constructed it with a compass. You can also construct it with patty paper, with a mirror. There are lots of ways to do it. But on your quiz, you're just going to be asked to draw it, not do an actual formal construction. So let's start with the medians. And to be able to draw it means you need to know what it is. Okay? A median is a segment that goes from a vertex. So a vertex means any one point. I'm going to pick a point to the midpoint of the opposite side. So what I would do is I would try to estimate the middle of this side over here, opposite side. Say it's probably about right there. And then I connect them. Okay, now, the thing that shows it's a midpoint is the markings that I'm going to put on here. So if I'm trying to do this on a test or quiz or whatever, I need to show that I know this is supposed to be a midpoint by making congruence markings on either side of it. So that is a median. Okay, now if I'm asked to draw all the medians of a triangle, I have to do that from each vertex. This is a vertex. Go from the vertex to the midpoint of the opposite side. So I would go from this vertex to the midpoint of this side. And again, to show that it's a midpoint, I put congruence markings on either side. So now I'm going to connect those 2 points. And the last one goes from this vertex down here to the midpoint of this side here. And I need congruence markings to show that it's a midpoint. I don't know if I put that exactly in the right place, but it's pretty close. Okay, so I just drew all 3 medians of this triangle and I marked them correctly to show that they're medians. You have to not only be able to do this, but you also have to be able to recognize this, so that if I look at a triangle that is marked this way, I know that AB is a median and CD is a median and EF is a median. Okay, so that if I see this picture and somebody says what type of special segment is illustrated, I say, okay, it's a median. Those are all medians. Now the other thing about the medians is where they meet. They meet in a point called the centroid. So this point of concurrency, which just means a place where a bunch of lines meet, that point of concurrency is called the centroid. Okay, the centroid is 2/3 of the way from the vertex to the opposite side. So that means, for instance, for segment FE, if I think of FE by itself, and here's the centroid, then 2/3, that means 2 parts out of 3. So let's think of dividing this into 3 parts. If I divide that into 3 pieces, 2 of the pieces are on the long side and 1 piece is over here. So that tells me that, like, for instance, if the whole thing was 18, I would divide by 3 to see what each of these pieces is. They'd each be 6. That would also mean that this side over here would be 6 twice, which is 12, and this part would be 6. So this side is always going to be twice as big as this side. The bigger part from the centroid to the vertex is always going to be twice as big as from the centroid to the midpoint. So for instance, on this segment, from D to the centroid is twice as long as from the centroid to C. So if this was 10, then this would only be 5. And the length of the whole segment DC would be 15 because I'd put 10 and 5 together. Okay, so that's the basics on medians. Let's look at how I'm going to draw altitudes if I was asked to draw altitudes. Okay, actually let's not do altitudes quite yet. Let's do angle bisectors. Okay, so angle bisectors. Angle bisectors have to go right through the vertex of the angle. So they're going to go right through the point here right through the point here and right through the point here. And they're going to go through there like this in a way that divides this angle into two equal smaller angles. So if you're just drawing it, you're kind of estimating that. You're trying to go right down the middle. So let me draw this. Ooh. There's an angle bisector. And I put these little matching arcs to show it's an angle bisector. Notice that it does not come right in the middle of this piece over here. It doesn't have to. It just has to have two equal angles. So now I'm going to do one here, right down the middle of that angle. And I show that it's the middle of the angle by two little matching arc pieces. And then I'm going to do one up here, right through the middle of that angle. And my drawing's probably not perfect, but as long as it's somewhere close, the most important thing is the markings to show these two angles are the same. These two angles are the same, and these two angles are the same. So if you see congruent angle markings like this, that's what tells you you have angle bisectors. Okay, that's what's telling us that. So that means, in other words, for instance, if I have, let's call this whole big triangle ABC, and these little points QRS. So for instance, angle ACR, again that's here, ACR, which is this side, is the same as BCR on the other side. BCR right over here. Okay, so congruent angle markings tell us we have an angle bisector. Now, the angle bisectors are also concurrent. Remember, concurrency just means they're coming all together at the same place, a bunch of lines crossing in the same place in one point. This point of concurrency is called the incenter. So angle bisectors meet at the incenter. You need to know that. You need to know that if you look at a picture that has a bunch of congruent angle markings, that's what you're being shown is the angle bisectors. And you need to know how to draw it like I just did. Okay? The special property of the incenter is that it is always located right in the middle between all the sides. So if I were to draw a segment from here straight to the side, and notice that this one doesn't go straight to the side, it kind of goes off to an angle. So from here straight to the side, and from here straight to the side, and this one looks pretty straight to the side, but we have to have a little right angle to tell us that that's straight to the side. All these little red segments I just drew, those are all the same. From here to here, from here to here to here, and from here to here. Each one of those has the same length. I know this one looks longer, but that's because I drew this by hand and did not construct it. Okay? So the angle bisectors are always concurrent in the incenter, and the incenter is equidistant from the sides. Again, this information is in your chart. But I noticed that not everybody completed all of their chart. That's why I'm showing you this, is because I noticed several people did not put the markings on the triangle. And the markings are important because they show me how I'm supposed to know just from looking at any random triangle what's an angle bisector and what's a median. Okay, I need to know that these markings tell me it's an angle bisector, whereas these markings tell me I have a median. Okay, now, if I have segments that go through the middle of the side and also go through it at a right angle, and since we're not constructing here, the easiest way for you to kind of ballpark a right angle would be to take another piece of paper, even another page of your quiz or scratch sheet, and every paper has 4 corners. A corner is a right angle. This is a 90-degree angle right here. Okay, so if I want to make sure I'm doing a right angle, I probably do this. Notice that the edge of my paper is right up next to this line. Okay, and I'm going to draw right across here. Now this is a perpendicular bisector because I made it to be a right angle, so I'm going to mark the right angle, and it cuts the segment in half right in the middle. It goes right through the midpoint, so that's called a perpendicular bisector. Okay, so perpendicular bisectors. So notice the markings. You have to see two things to know you have a perpendicular bisector. You have to see the right angle marking, and you have to see the congruence markings on either side. So let me go ahead and go right through the middle of this one. So if I'm trying to draw it by hand, that's what I start with, is I start by going to the midpoint and then using my right angle to figure out where it's going to go. Notice that it doesn't have to go through that point. Very often it won't. It doesn't have to go through the point on the other side. And last but not least, right in the middle of the side, I make a mark. I make my markings that show it's the middle. And then I use my right angle to try and make sure it's close to a right angle as I can make it. Sorry that I'm freehanding this instead of using a straight edge. Okay, so those are the three perpendicular bisectors. So these are also the markings I have to see if I'm looking at something and they're asking me, what is it? I have to see to know it's a let's say this is A and this is B. So in order to know that AB is a perpendicular bisector, I have to see the right angle where AB meets the side, and I have to see that B is right in the middle by seeing the congruence markings on either side. The perpendicular bisectors are also concurrent. They meet in a point called the circumcenter. The special thing about the circumcenter is that it is equidistant from the vertices. So if I go from here along this dotted line to that vertex, or to this vertex, or to this vertex, those dotted lines are all going to be the same. So if we call this, let's call this C. From C to Q, C to R, and C to S, those are all congruent. So the circumcenter is equidistant from the vertices. Okay, last but not least, we have the angle bisectors. Excuse me, I'm sorry. The altitudes. We already did the angle bisectors. The altitudes of a triangle. The altitudes don't have to go through the middle of the side. They do have to go from a vertex. And what they do is they go from that vertex across to the opposite side, or the line containing the opposite side. It could be sometimes that your altitudes will go outside the triangle, but right here we're using an acute triangle, so it won't go outside the triangle. In an obtuse triangle, it would go outside the triangle. On a right triangle, it would go right down the side of the triangle. But the key thing here is it just has to go from that point across the triangle and make a right angle with the opposite side. So I'm using my straight edge that has a nice little right angle to show me where this is going. So here we go. We have a right angle and it goes through the vertex. So that's how I know it's an altitude. It has to touch the point. It has to go from the point, any point on the triangle, to the opposite side or to the line that the opposite side is on in a way that makes it hit there as a right angle. So for my next altitude, I'll find the next vertex, and then I'm going to make it a right angle from that vertex. Notice that I can see the vertex on my piece of paper, and I have that lined up so that it goes right there, makes a nice corner. That's all a right angle really is just a special, a sharp corner, a perfect corner. And last but not least, going to go from this side, or that vertex rather, and I'm going to make it a right angle. Ooh, excuse me. And there we go. And those are my altitudes. Notice that there are no congruence markings for altitudes. There's no angle congruence markings. There's none of these little marks that show me I'm at the midpoint. None of those. All that you see when you're looking at altitudes only is just right angles. The altitudes also come together all in one point, which is just said by the word they are concurrent. And that point is called the orthocenter. Orthocenter is the easiest one because there's really nothing special you need to know about it. And that pretty much reviews the 4 special types of segments that are concurrent in triangles. In other words, all of these 4 types of segments come together in one point. Now, we also have one other type of triangle segment that we've talked about, and that's the midsegment. So let's just look at that real quick. The midsegments don't meet each other in just one point. They make a whole separate triangle inside the triangle. So if you see a triangle inside a triangle, chances are you're looking at midsegments. Midsegments go from one midpoint to another. So the way I would draw them is I would start out by just finding the midpoints. And you're kind of guesstimating. That looks like it's in the middle there. And this looks like it's in the middle here. And this looks about like it's the middle here. So I drew all 3 midpoints. I've got 3 sides, so that's 3 midpoints. And then I connect any 2 of them, and that's a midsegment. So if I connect these 2, I just drew a midsegment. If I connect these 2, I just drew a midsegment. And finally I can connect these 2, and that will be a midsegment also. So you see how there's a smaller triangle inside the bigger triangle, and that's what we generally see when we have midsegments. The special things about midsegments are this side is parallel to this side. Every midsegment is parallel to the side it doesn't touch. Okay, so those 2 that I marked parallel are parallel. This one and this one are parallel. So every midsegment is parallel to the side it doesn't touch. And it is half as long. So for instance, if this whole blue segment is 10, whole thing is 10. Well, notice that this is a midpoint, so that means I really have 5 and 5. Well, this would be half of 10, which is 5. And that's pretty much it for special segments you're going to need to worry about in triangles. Thanks for learning.